In this video on graphing lines, we're going to continue to look at equations and their graph solutions. So if you will recall from another section, we learned that the equations in two variables have infinite solutions. And the reason is, if you'll think about it, is because those equations always graph to form a line, and lines have an infinite number of points on them. You're not going to plot an infinite number of points, but lines do have an infinite number of points. So for example, if we have an equation x plus y equals 4, what I want you to do, I want you to pause this video after you make this xy table, and I want to see how many solutions can you list for x plus y equals 4. Try to do it on your own by pausing and not just looking at what I'm going to write and then come back. All right, I'm assuming that you paused and that you are now back, and I don't know what your solutions are, but I'm going to list some of them that do work. Remember, they have to make, to be a solution, they have to make this a true statement. So doesn't 4 plus 0 make 4? And 3 plus 1? And 2 plus 2, and 1 plus 3, and 0 plus 4, and negative 1 plus 5, and couldn't I keep going forever and ever and ever? I ran out of space. Let's do another one. How about 3.5 and 0.5? Don't those go together to make 4? So I could even include fractions. There's a lot of things that I could do. I could have 5 and negative 1. That makes 4. So all of these, I'm going to pick a few of them to plot. All of those are solutions to the equation x plus y equals 4. So if I plot them, here is the point 4, 0 right here. Then we have the point 3, 1. We have the point 2, 2. We have the point 1, 3. We have the point 0, 4. We have the point negative 1, 5. We have the point 5, negative 1. And you can see quite easily that all of those points line up when I plot them. I didn't exactly hit all of the points, and they make a straight line. They are all solutions to this equation. Now, it was easy to look at this equation and come up with these. It isn't always that easy. I could just look at things that when I add them together, they make 4. So it says, what do you notice about your plotted solution points? Again, they make a straight line. We talked about that in another video. A linear equation in two variables is an equation that can be written in this form. Some number times x plus some number times y equals a third number where a, b, and c are real numbers and a and b are not both 0. This form is called the standard form, and the graph of a linear equation in two variables is a straight line, as we just said. So examples might be 3x minus 2y equals 7. Or if the number in front of the x was a 0, it might be just negative 2y equals 7. Or 1/2 x plus 1/4 y equals 12, etc., etc. There are an infinite number of examples. So let's look at how we graph a linear equation when we do not have an xy table to start. We just have to make our own. So example 1 says, graph the linear equation 2x plus y equals 5. First thing you do is you set up an xy table. Now let's think about it. If we know that all the solutions to a linear equation form a straight line, how many solutions do we really need before we can draw that line? We really only need 2. Having 3 is kind of a good insurance policy, but so we'll do 3. How do I find them? Well, on this equation up here, when I had x plus y equals 4, it was easy. I could tell by looking. Not so easy with this one. So how do you do it? Well, I'm going to give you a little tip. If one of your variables, either the x or the y, has a 1 in front of it, an implied 1, in this case the y does, what you want to do is you want to pick numbers for the other one. And yes, I said pick. You can pick anything you want for the x value and then solve it for the y using that value. So for example, I want to pick easy, I'm going to pick a 0. So that would give me 2. Take out the x, put in a 0, plus y equals 5. 2 times 0 is 0, and we have just y equals 5, and there I have a point. I want another easy one. I'm going to pick x being 1. That would be easy. 2 times 1 plus y equals 5. 2 plus y equals 5. Let's subtract a 2 from both sides, and we get y equals 3. Now that's enough for me to graph my line over here, but I'm going to do one more just to be safe. I'm going to pick -1. Remember, I can pick whatever I want for one of them and then solve for the other one. So let's pick -1. I may have to raise this up a little bit so you have room to see. So that would be 2 times -1 plus y equals 5, or -2 plus y equals 5. Add a 2 to both sides, and we get y equals 7 when x is -1. I now have 3 points, so let's go plot them. Here's the point 0, 5, 1, 1, 2, 3, and -1, 7. Do they make a straight line? They absolutely do. And that's the advantage of going ahead and doing a third one, just to make sure that they all are going to line up and you didn't make any mistakes, like a sign error. All right, let's try another one, and I'm going to show you some more tricks for how to know which numbers to pick. So let's look at this equation. -5x plus 3y equals 15. Okay, what I just told you in the last one doesn't apply here because neither one of the variables has a 1 in front of it. So I'm going to make my xy table, and remember, I can pick whatever I want. So I'm going to pick a 0 for the x, and I have to put it in and solve for the y. So -5, take out the x, put in a 0, plus 3y equals 15. That makes a 0. 3y equals 15. Divide by 3, and I have y equals 5, and there is my first point. Now I don't want to end up with fractions, so how do I know what would be a good choice for my next point? Well, I picked something for x. I picked a 0. I'm allowed to pick something now for y, and guess what I'm going to pick? 0. I'm allowed to do that. So that would give me -5x plus 3. Take out the y, put in a 0, equals 15. Now this goes away, and I have -5x equals 15. Divide by -5, and we get x equals -3. And in this case, because I don't have a 1 on either one of my variables, I'm only going to pick those 2 points. Hope I didn't make a sign error, which I did not, and we're going to plot those. So the point 0, 5 is right here, and the point -3, 0, -1, 2, 3, 0 is right there. And when I put my ruler down and connect the two, I have graphed that equation. Don't forget to put arrows on the end. Don't just connect the 2 dots. Make it go through the dots, through the points. All right, let's try another one. This one is a little bit different. It's set up differently. It says y equals 3x. Okay, xy table. If you'll remember in example 1, I told you if one of the variables has a 1 in front of it, this y does, pick for the other one. So we're going to pick for x. We're going to start with a 0. So y equals 3. Take out the x, put in a 0, or y equals 0. Now let's pick a 1. Y, still for the x I picked. 3 times 1, y equals 3. There's another solution. And now I'm going to pick a 2. I can pick whatever I want. Y equals 3 times 2, y equals 6. And I have 3 points. Very, very simple. By remembering that little shortcut hint that if one variable has an implied 1, pick for the other one. So let's plot. 0, 0 is here, 1, 3 is here, and 2, 6 is here. And when I connect them, once again, you see that they form a straight line, and we have graphed that equation. All right, let's do 2 more of these. These are a little different, and this is where I told you in another section that when you have a fraction, you can still maintain control. So in this one, I have a fraction, but the y has a 1 in front of it, so I'm going to pick values for x. So I've got my xy table. Now I want to pick a value for x. That would be, make this easy. So I'm going to pick a 0. So that would be y equals negative 1/3 times 0 plus 2, or y equals 2. Now, in the examples prior to this, I've picked numbers like 1 and negative 1. What do you think would be a better pick for the x here? Think about it. I don't want to have to deal with a fraction. I'm going to pick a 3. Do you see why? Because that's going to give me something that cross cancels my denominator. Now I still have the plus 2 here. So I got rid of my fraction by picking smart for the x. So now I've got negative 1 plus 2, or y equals 1. Okay, now we have enough to graph it, but I want to keep going. What would be another smart pick for x? What about negative 3? Y equals negative 1/3 times negative 3 over 1 plus 2. Doesn't it still cross cancel? Now I have a negative 1 times a negative 1, which is a positive 1 plus 2, which is 3. Just to kind of make my point, what would be another smart pick for x? Y equals negative 1/3 times, what else would make that cross cancel? 6 over 1. I could pick a 6 for my x. That was a 2. That's going to give me y equals negative 1 times 2, negative 2 plus 2, or 0. So when you have a fraction, if one of the variables has a 1 in front of it, anything I want to pick for the other one is just something that will cross cancel that denominator. So let's graph these, or plot these points. The point 0, 2, the point 3, 1, the point negative 3, 1, 2, 3, and the point 6, 0. And once again, you can see, because we did it correctly, they are all solutions, therefore they all line up, and that is the graph of that equation. So the fraction really wasn't a problem. All right, this last one is different. First off, how is this equation different than the others? Y equals negative 2. There is no x in the equation, right? Well, it really is there. It's really 0x plus y equals negative 2, but we're not going to show that. So what you do is you go to your xy table, and this is telling you y has to be negative 2. You have no choices. So we're going to go put in negative 2 for y. We have no choices. Y has to be negative 2. So what is x? It doesn't matter, because look at it. It was going to be multiplied by 0 and go away anyway. So it can be a 0, it can be a 2, it can be a negative 2, it could be a 14. It doesn't matter, because it's going to be gone. What matters is that the y has to be negative 2, because the equation says so. So watch what happens when I plot those. 0, negative 2 is right here. 2, negative 2 is right here. And negative 2, negative 2 is right here. So when I connect them, what kind of line do I have? I have a horizontal line. A horizontal line. It says, what conclusions can you make about this kind of equation? If you have y equals some number and there's no x, it will always be a horizontal line. Always. So what do you think, let's do this in a different color. What do you think the equation x equals 4 would be? Well, let's do it real quick. X equals 4. We have an xy table. This is saying x has to be 4. We don't care what y is. So I always use those 3 numbers. That gives me 4, 0, 4, 2, 4, negative 2. Oops, I went down too far. And what kind of line is that? That is a vertical line. So x equals some number is always a vertical line. Y equals some number is always horizontal. X equals some number is always vertical when one of the other variables are missing.